Okay, so we're gonna discuss a couple of important topics. Uh, so first is why mobile testing is different and what to test in mobile user experience. So we'll cover two things: why testing is different on mobile, and the mobile user experience testing essentials. So again, we'll use one example. It's called, I think it's called Campus Event app, where students browse events and RSVP. So yeah, so why mobile testing is different? So mobile is different from desktop because the environment is less predictable. Phones vary a lot, and people use apps while moving with weak signal and with limited battery. Um, so there are some guidelines for mobile, like for guidelines for testing in mobile. First is you test on multiple devices and multiple screens, not just one phone, and you test on different operating system versions, because behaviors can change. And test you should test under real network conditions like slow data or no signal. And then you also test with battery and performance, because heavy apps feel broken. And you test the permissions and privacy like location access, camera access. And then we test the interruptions, so because mobile users get calls, text and notifications. So yeah, that's one thing you need to test. So in a campus event app, imagine everything works on your phone at home on Wi-Fi, but a student on campus has poor signal. The app might fail to load events. So things like that. So that's why mobile testing is not just does it work. It should be like, does it work well in real conditions. And the main mobile testing strategies, we have few simple strategies, usually development teams use, which is, the first one is functional testing. Like for example, does the feature work, like RSVP and search. So then it then comes compatibility testing. So does it work across devices, screen sizes and operating system versions. And then we have network and offline testing. Basically, what happens when a app is interrupted and then resumed. uh, Sorry, that's it for interruption and recovery. So the network and offline testing is basically, can users complete tasks easily on a small screen. So and then we'll check what happens with slow, weak or no internet. So things like that. And we have some mobile user experience testing essentials, which is basically, gestures include, we have gestures testing, which include tap, long press, swipe, scroll. So on mobile, gestures replace mouse clicks, so they must work smoothly and consistently. And then we have virtual keyboard testing, which is mobile keyboards cover part of the screen. You change the layout and sometimes autocorrect. So forms often break here. So uh, yeah, that's one thing to keep in mind. And then we have voice input testing. So some users use voice input for accessibility or convenience. So voice recognition can misunderstand words, so the app must handle that. And then we have alert and unusual conditions. Mobile apps face many unusual conditions like notifications, incoming calls, low battery, app switching, things like that. So testing must cover how the app behaves through these events. So mobile testing is different because devices vary, networks fail, and interruptions happen constantly. So good mobile testing covers real conditions plus user experience essentials like gestures, keyboard behavior, voice input, alerts, so the app stays usable in everyday life. So that's about mobile testing. Then we have web application. So again, we'll cover two topics here: web application testing basics and the two most important non-functional tests that usually teams often forget until it's too late, which is the security testing and performance testing. So again, we'll use one example: the online course website, where students view modules and submit assignments like an LMS. So so first we have web application testing basics. So web apps are tested a little differently because users can access them on many browsers and many devices and many screen sizes. So also web apps depend on links and navigation, and small UI issues can break the whole experience. So a simple way to think about web testing is to focus on three areas: the content, the interface, and the navigation. Uh, and then we have the content testing. So content testing checks that the information on the site is correct, complete and readable and up to date. So this includes text, dates, files, images, links to resources. So like for example, on a course website, content testing means checking assignment due dates match the syllabus, the right PDF is attached, not the last semester file, videos open, so things like that. Then comes interface testing. So interface testing checks whether the web page elements work correctly. This includes forms, buttons, uploads, error messages, and feedback after actions. So, like for example, on an assignment submission page, interface testing checks the upload button works, the site accepts correct file types, and the site rejects the wrong file types with clear message. So things like that is comes under interface testing. And then we have navigation testing. So navigation testing checks the users can move through the website correctly and consistently. Like it includes menus, links, back button behavior. Uh, like for example, on a course website, navigation testing checks modules, assignments, grades, links always go to the right place. The correct page is highlighted so you don't know where they are. So things like that goes to navigation testing. Excuse me. And critical non-functional testing. So non-functional testing is not about features, it's about how the system behaves under stress and under attack. So two key ones are the security and performance. So security testing ties to prove the system protects data and blocks unauthorized actions. So it answers questions like, can users access things that they should not access? Can someone break the system by entering malicious input? So and are logins and sessions handled safely? So those kind of things go to security testing. And then performance testing. So performance testing tries to prove the system stays fast and stable under expected and heavy load. So it answers questions like, how fast does the site respond? What happens when users log in at once? Uh, and does the system slow down or crash? So those kind of testing goes into performance testing. Pretty basic, nothing very complex. Uh, then next we have we'll cover the software configuration management, or SCM. This is how teams keep software organized as it changes over time. We'll cover version control, continuous integration, and change management process. We'll use again one example, the same example, online course website. So first is the SEM. SCM is the set of practices and tools that control changes to software. It keeps track of what changed, who changed it, when it changed and what version is safe to release. So SC, SCM matters because software is always changing. Without SCM, people overwrite each other work. Bugs return after being fixed. Nobody knows what version is running in production, and releases become risky and chaotic. So, for example, imagine two students on a team update the assignment upload feature. One fixes a bug and other changes the UI. Without SCM, one person might accidentally replace the other person file and you lose work. So with SCM, both changes can be tracked, reviewed, and merged safely. And then we have configuration items. So configuration item is anything you need to manage and keep consistent for the project. So this includes more than code. It Common configuration items are like source code files, test cases, test data, a requirements document, design diagrams, so those kind of things. And then we have baselines. So baselines is a known goods snapshot of a project at a specific time. So it is what you can return to if something goes wrong. Like for example, before releasing the course site, the team creates a baseline version called release 1.0. If a later change breaks uploads, you can compare to the baseline and see what changed, or quickly roll back to the baseline so students can submit assignments. Then we have managing dependencies and change. So software depends on many things like libraries, APIs, database versions. Managing dependencies mean making sure the project uses right versions consistently. Like for example, if one developer updates a library version and another developer does not, their code may work on one machine and fail on another. So SCM helps look dependency version so everyone builds the same software. And We have SCM repository purpose and the version control system. So a repository is a central place where the team stores and tracks project versions. So version control system records every change and supports collaboration. So common capabilities are commits with history, branches for working safely, merging changes, rollback to older versions. Like for example, one student creates a branch to add a late submission policy feature, and another fixes a grading bug. So version control lets them work separately, then merge changes without issues, and keeps a record of who changed what. And then we have a continuous integration, which is CI, means every time code changes, the system automatically builds and runs tests. The goal is to catch problems early. Like for example, one person pushes code that accidentally breaks the upload feature. CI runs tests and fails immediately, so the team fixes it right away instead of discovering the problem during release night. So CI is basically a safety check that runs constantly. And then we have a change management process. So change management is how teams control changes so quality does not collapse. So it usually includes change control, which decides which changes are approved and what they are included. And then we have impact analysis, which checks what the change affects uh, code tests and documentation, database, timeline, so everything. And then we have audits. Audits confirm the change was implemented correctly and follows standards. And then we have status reporting, which tracks what changes are planned, in progress, tested, or released. So SCM keeps software stable as it changes. Configuration items, baselines keep releases controlled. So version control supports teamwork. CI catches problems early, and the change management ensures changes are approved, understood, tested, tracked. So yeah, that's all for these topics.